agent memory. So the agent memory package is available on PyPy and GitHub. You can go to pypy.org/projects/agentmemory, and you can find it right here. And you can also pip install it with agent memory, right? Pip install agent memory. Nice and simple. And you can see we have a quick start here, which shows you some things like creating a memory. You can search for memories, and when you search for memories, that will bring back an array of objects, which are individual end memories, which have this kind of structure: ID, document, metadata, and embeddings. And you can see debugging, you can see basic usage guide, and then a full API reference, which contains arguments, examples, the whole deal. Cool. So this also connects to our GitHub, which is right here. And you can see that we have the same stuff reflected here because the README is actually published from here. So you can see we have releases, but I suggest just going to the PyPy and going from there. So let's look at the code. All right, so our tests are actually also in the agent memory package, but they're entered from here, agentmemory.tests and test.py. So you can see in here there's test folder, which corresponds to the agentmemories.tests. And inside there are tests that correspond to each of these files out here, or at least there should be. If I want to run the tests, let's see, I have to activate conda because I need Python 3.10. I wish I have an environment because there's some bug with Python 3.11 and PyTest. So let's do python-m pytest test.py, and that will go through and run all of the memory tests. You can see and validate that they all work. 19 passed, great. So if I want to, you can see examples of how all of the agent memory modules work inside of the tests. For example, if I go to helper, you can see that test chroma collection conversion, get chroma client. These are kind of some of the deeper things that you might not see in the API. Main is probably the stuff you would mostly see, which is like test memory creation and retrieval. And you can see sort of examples of how that's being done. Create a memory, get the memories, assert that there's 10 of them. And so this is a good additional documentation source, is all of these tests right here. If you want to see how something is supposed to work, you can look at the tests and see that, well, this is what we're expecting it to work. There's probably some edge cases we still need to add. And so, yeah, a big thing that we're looking for contributors to do is look through the tests and add more stuff, try and break it, try and add more tests to make sure it can't be broken, etc., etc. So that's the test. Let's look at the main code. We have kind of all of the main code, like the stuff that's exposed as an API, the stuff that the user is actually going to import from the package is all in this main.py. And you can see we have the function headers here for all of that, and I can expand all of those. You can also get access to the client, like you can get the Chroma client, but generally that's kind of lower level. So one thing we should talk about is like, what is agent memory? It is a library for agent memory, obviously, but it's also a wrapper to on top of ChromaDB right now, and maybe eventually something else, Postgres or something, whatever. We'll figure it out. But mainly right now, ChromaDB, because it's very simple, it just works, it installs. But the API for it's a little complicated. Like, it doesn't give you back objects completely. It gives you arrays of things that you have to go grab pieces from. It's not great. I mean, you can see, like, we have all of this code here, and all of this code is basically doing stuff that a lot of it I feel like Chroma could do themselves. But we want to make the API a lot simpler, so we put all the boilerplate into this package. It's basically wrapping ChromaDB, making it a lot easier to use, adding a lot of handlers and like validation and debug issues and stuff that just makes it a lot easier to work with. And also, I feel like the having a really nice plain language interface, like create memory, create unique memory, it's just better than like get collection by ID. I don't, we're trying to avoid that and try and bring it back into like a kind of human language like realm and make it reasonable. So that's a lot of why this kind of exists. And you can see a lot of these, like search memory, takes a lot of different arguments. And you can see there's a lot going on. We want to search, we want to We have like a unique filter so that we can uh, add unique memories, which are memories that, like, if you add something 10 times, then we only want to pull it back once. Stuff like that, things that are useful for people doing agent memory kind of things. Um, so yeah, let's go through it really quick. The first thing you're going to do obviously is create a memory. Memories take a category, so like that could be tasks, and they also take some text. The text would be like, whatever you want, but this is what's actually going to get searched, is this text thing. This is like what is searchable. This gets stored as the document. The metadata is going to be like anything you want to store on that. Like, you want to store steps. Great, you want to store steps. Or that's awesome, but steps is probably an array, so you're going to have to make sure it's a string. So metadata is integers, strings, basic types like that. If you have anything like an array or a dictionary, you're going to have to stringify it with JSON stringify, and then you could have like timestamp or related to, or whatever you want in the metadata additionally. Embeddings is a really important concept here. So embeddings are the actual like vectors. It's usually a vector of basically an array of like 512 numbers, sometimes 1024 numbers, depends on which model you're using. And it's gonna, we use those for doing similarity comparisons, distance comparisons, various kinds of sorting. And so like the embeddings are great, but for a lot of things you might not need embeddings, and they can be kind of just like a lot of data to get shoved around, because it's a big array of numbers with everything you send around. So for IDs, when you create a memory, it automatically increments the ID. The way Chroma is set up is that IDs are strings, and there's this kind of annoying thing with strings where they have to be padded. So like you probably just want to use the built-in ID system for agent memory, but you could push your own ID, and that could literally be anything, but it does have to be a string. And you can see that if it's not a string, let's see. Yeah, you can see if it's not a string, we will string the ID to make sure it is a string. So you could pass like an integer or something into there, but just know that like all IDs are strings. Cool. We have create unique memory. So creating unique memory is the same thing as create memory. This is a new experimental API. Maybe we'll consolidate it. But the goal here is that if it's really similar to another memory, we're going to do like a search and and check if it's similar to other memories. And if it is, then still put it in the database, but add that it's false, that unique is false. That's kind of, that way when you search, you can search by uniques. Search memory, you can, if you want to search by uniques, you can. The idea is like, just give me everything, or just give me the stuff that doesn't have anything super similar. And the reason we added this is because we're doing like knowledge, basically like creating, building knowledge graphy kind of things, or building knowledge for an agent. You really need to deduplicate stuff so you don't get too much overrepresentation of certain kinds of things. And also, like, when you're just like passively like running a learning step on something, like oftentimes you'll end up picking up the same information multiple times, and it's just like, it's just a way to kind of filter out some of that noise and get a more varied kind of response, because you usually don't need like repeats of stuff. But we also still want to add it to the database so that we have like the event happening. So that's why we're tracking if it's unique or not across like a lot of these different functions. So like the first one that gets added that's not similar to any other one will be marked as unique. Any others that are very similar to that will be marked as not unique. Cool. So search memory, same thing. You can search by category. Category be tasks, I don't know, conversation, whatever you're storing. Search text is going to search through the document, so it's whatever you store it as, the content or the text for here for create memory. Number of results, obviously how many it's going to return. Filter metadata, so you saw that we added metadata here, like unique true, or updated related to. These are the kind of the unique handlers, or here like created at, updated at in the create memory. Cool. And so filter metadata lets you filter by that metadata. There's some sorting you can do. You could say like, hey, I want only memories greater than this timestamp or something, blah blah blah. But like, and that all comes from Chroma. This is just like borrowing their language. But for the most part, you're just saying like, I want all conversations where the sender was this user, right? For example. So that's kind of how you would filter your search. You can see contains text. So as opposed to so remember, we're doing a vector search, so it's conceptual. It's not doing a direct word for word search. It's searching the vectors. But you can also do a contains text. Make sure it contains some text. It has to contain this word or this phrase. Do you want to include the embeddings? Yes or no. Do you want to include distances? The distance is a number between 0 and 1 of how far away any response, like any item, is from what you search for. 0 would be it's the exact same. 1 would be it could not be possibly more different, right? And then maximum distance. So you could say, like, I only want to search for things that are more different than this thing. I don't want anything that's kind of close to it. Or you could say, I only want things that are very close to it. And so that's how you control, with these distances. So these are between 0 and 1. Cool. Okay, get memory. So instead of searching memory, right, search gives you back like a list of results based on the relevance distance from the search text. You can also just like either get a direct memory, a single memory by ID, or you get a list of memories from get memories. And you can see this is going to have like a sort order. So you can get the first or last, and you can also get number of results. So let me give me the 20 last most recent ones, right? Would be descending order, 20 results. But if I want all of them and I want them in, from the beginning to the end, then I might want ascending order, and I would want end results to be like 1,000 or n, I don't know, whatever, none. Same thing, include embeddings, contains text, filter metadata, unique. Same kind of deal as search. It's just slightly different that instead of searching text, you're just getting some from that category. Update memory. Obviously you take a memory that you already have, you update it. You can set text, metadata, or both. If you set neither of them, then it's not going to do anything because you're not updating anything. But if you set text, it'll update the document. If you set the metadata, it'll update the metadata to whatever that is. You should make sure you have to update with the complete metadata. It doesn't it doesn't know because the goal is that you're actually updating the entire metadata field at once. So you have to make sure that you return all metadata into the update memory. Delete memory, obviously, just delete one by ID. You can get a memory and then get the ID from it and then delete it by ID. Delete similar memories. So this is actually saying like, hey, find anything that's like this content, find and remove. You could use that for a content filter, various kinds of conceptual things. But yeah, there's this idea of delete similar memories. You can check for memory exists, right, at that ID. You can count how many memories you have in the category. Each category has some. You can wipe a category, which erases all of them, and then you can also wipe all categories, right? Wipe all memories. So, sorry, I'm speaking a little fast, but that's kind of a walkthrough of all of the different functions. I kind of went through the top ones in more detail because I think that they contain a lot of the new concepts. The rest are kind of like, you get it. It's CRUD, it's get, update, create, delete. And you can see that we have some other things like export memory to JSON and export memory to file. And we also have the opposite, import JSON to memory and import file to memory. And that basically just takes the entire database and serializes out to JSON or back. Because we're including embeddings, these can get very large. If you had 1 million lines, it can easily be a gigabyte. So just to be aware of that, because basically JSON formatted floats are just very large. And there'd be a lot of them for all the embeddings. And then we also have the client. So the client is just like, hey, everything here is wrapping ChromaDB. So if you actually need access to ChromaDB, you can get the Chroma client, and then you have access to the full API and everything you would have from ChromaDB. Cool. Not much else to it. I mean, maybe I'll show you the last thing, which is publish flow. So I have this version. It's passing everything. I look and I say, great. I get push origin main and love it. Very happy with it. Now I go to my GitHub. And if I go to releases and I draft a new release, I can create a new tag like v0.2.14, create the tag, maybe I'll just do 0.13. See, I have the tag, and then I publish the release. When I publish the release, it's going to show up here. And you can see v0.2.13, and I have all of my sort of change notes. And that's kind of how we do it. Now, when we publish here, this is also going to go to the PyPy. So you can see here, 0.2.13, and all of this is identical. And basically, this has a workflow. So let me just show you the workflows really quick. Inside of this GitHub folder, there's a workflows, and these workflows control, one, the tests. All the testing is run here. You can see we're using Python version 3.10. We're calling pytest test.py, which is this file. And we also have the publish flow here. You can see it's just installing everything, building, and then calling build, which loads the setup.py, and then publishing to PyPy. PyPI? I don't know. PyPI, I think, is the correct thing. Lastly, you see this setup right here. This setup is where all of the info is happening. This is what actually gets published to PyPI in the package, and what pip reads. You can see it's just reading the README MD in, and that's what gets published as the the information here. I guess the long description, and then the rest is just pushed here. So cool. I think that's a complete overview of the entire project as it stands, and I hope that was really helpful.